In today's video, we're diving into the spellbinding world of bioluminescence, one of nature's most magical phenomena. Have you ever gazed upon a calm sea at night and noticed a strange, mystical glow beneath its surface? Or perhaps you've been on a nighttime hike and seen the forest come to life with tiny, twinkling lights. That, dear watchers, is the artistry of bioluminescence at work, a brilliant example of the natural wonders our world has to offer. So what exactly is bioluminescence? It's the ability of living organisms to produce and emit light through a series of chemical reactions within their bodies. The essence of this phenomenon is the enzyme luciferase, which acts on the molecule luciferin, triggering a reaction that releases energy in the form of light. This enchanting process has evolved independently many times across different species, which means that bioluminescence can be found in a variety of ecosystems across the globe. Before we immerse ourselves in the glow of these enchanting creatures, let's illuminate our path by hitting the like button and subscribing to our channel, ensuring that you're always in the loop for our exploration of Earth's captivating charm. Feel free to share your thoughts or experiences with bioluminescence in the comments. We'd love to hear your glowing stories. Now let's float into the first example of bioluminescence on our list, the enchanting sea sparkle, also known as Noctiluca scintillans. Picture the ocean at night, suddenly bursting into a galaxy of blue stars as the waves crash. This incredible display is courtesy of Noctiluca scintillans, a type of dinoflagellate, a single-celled organism that calls the sea its home. When disturbed by waves or movement, they create a mesmerizing light show that's not just beautiful but also serves as a defense mechanism, startling predators and buying the cells time to escape. It's important to note that while this phenomenon is stunning, it's also a signal of changes in our ocean's health. Blooms of Noctiluca scintillans are often associated with water pollution and can have detrimental effects on marine life, including fish. Researchers have been closely monitoring the increase in these occurrences to understand better the environmental factors contributing to their proliferation. Transitioning to our next radiant denizen of the deep, we turn our attention to the deep-sea-dwelling creatures, such as the lanternfish. These small but mighty swimmers are named for their brilliant bellies, adorned with patches of light-producing organs called photophores. With these natural lanterns, the fish can communicate, find mates, and most intriguingly, engage in counter-illumination. This awe-inspiring tactic involves matching the light from the surface to mask their appearance from predators lurking below, rendering them nearly invisible. It's a fascinating example of how bioluminescence has developed as a survival strategy in the ocean's obscure depths. Lanternfish are not just bioluminescent marvels. They're also a cornerstone species in marine ecosystems. By feeding on plankton at night at the surface and then descending into the depths at dawn, they play a critical role in the ocean's carbon cycle, effectively transporting carbon dioxide from the surface to the deep sea. These glowing guardians of the sea illustrate how bioluminescence isn't just about beauty. It's integral to the health of our oceans. These two examples merely scratch the surface of bioluminescent wonder. From here, we'll proceed to unveil more luminous spectacles nature has tucked away. So, stay with us, and let's continue lighting up our understanding of these natural living lanterns. Continuing our journey through the world of bioluminescence, let's ascend from the fathomless oceans and venture into the mysterious night sky. Here we find the firefly, a familiar icon of twilight that has captured human imagination for centuries. These small beetles use their bioluminescence as a means of communication, seducing potential mates with a series of flashing signals unique to each species. Unlike our marine friends, fireflies produce a cold light with almost no heat, an efficiency that has intrigued scientists and engineers alike. The chemistry behind this cool illumination involves a compound called ATP, the proverbial energy currency of life, and it stands as a testament to how biological systems can achieve near-perfect energy conversions. But the firefly's light isn't just for show. It can also act as a warning. The light tells would-be predators that the firefly is unpalatable, and indeed, many firefly species are toxic or bitter to the taste. This combination of beauty and defense illustrates the diverse utility of bioluminescence and the intricate balance of nature's nighttime symphony. Before we proceed, remember, if you're enjoying this glowing journey, take a moment to comment below with your most luminous experience or fascinating fact about bioluminescence. And if you haven't already, consider joining our community by subscribing. Your support helps our channel continue to shine a light on nature's most marvelous secrets. Now, let's delve deeper into the terrestrial tapestry, to the world of fungi. Yes, you heard right. The kingdom of mushrooms holds its bioluminescent members, known as foxfire or fairy fire. These glowing fungi, found on decaying wood and forests around the world, have evolved an ethereal luminosity that beckons the question, why do they glow? One theory suggests it is to attract insects that will help disperse their spores, while another posits that the light simply helps them stand out in their dark, competitive environment. Whichever the reason, these mystifying mushrooms offer a glimpse into the lesser-known realms of bioluminescent life on land. Within the depths of the forest where these luminous fungi reside, they contribute to an intricate ecological web, breaking down dead organic materials and recycling nutrients back into the soil. This bioluminescent decomposition is a stark reminder of life's cyclical nature and the continuous exchange of energy that sustains our planet's ecosystems. We've now explored 4 astounding instances of bioluminescence in nature's grand gallery. Indeed, there are more sparks of life to uncover and more glowing wonders that twinkle in the darkened corners of our world. So don't let your curiosity dim. Stay tuned as we illuminate further secrets of nature's luminescent marvels. Our exploration continues, and the next creature on our list promises to be just as, if not more, dazzling than the ones we've already revealed. Stay with us, for the tapestry of light we are weaving is far from complete. In the next installment, we venture into the realm of squids, worms, and more, all shimmering architects of their own radiant masterpieces. As our journey into the mesmerizing world of bioluminescence continues, we explore an oceanic wonder, the Hawaiian bobtail squid. This charming cephalopod forms a symbiotic relationship with bioluminescent bacteria, which inhabit a special light organ in the squid's mantle. At night, these bacteria illuminate, helping the squid to camouflage itself against the moonlit water surface, a strategy called counter-illumination, which we touched upon with lanternfish. This spectacle of symbiosis between microorganisms and their host epitomizes the extraordinary ways nature co-opts bioluminescence for survival. The dance of light between the squid and its bacterial companions is a fine-tuned performance that has been perfected over millions of years of evolution. But the story of the Hawaiian bobtail squid and its luminous partners isn't just a tale of natural wonder. It's also proving to be a treasure trove for scientific research. Biologists are unraveling the molecular conversations that allow these two disparate life forms to communicate and collaborate. The insights gained from studying such relationships could pave the way for advancements in medicine environmental monitoring, and perhaps even the development of new forms of sustainable lighting technology inspired by nature's own innovations. As we marvel at the ingenious adaptations of these creatures, let us remind you, our curious audience, to light up the comment section with your insights or questions about bioluminescence. And if you're enjoying our deep dive into the glow of the natural world, do consider subscribing to ensure you never miss an episode on the fascinating facets of nature. Your support is a beacon that helps guide our content to new depths. Shifting our gaze from the ocean back to land, we encounter another earthbound luminary, the glowworm. These are not worms, but insect larvae, which have harnessed the power of light. Found in sheltered places like caves and dense forests, they create silk threads that hang from the ceilings or walls, which they light up with their glowing bodies. This bioluminescent trap lures prey, depicting another unique use of this radiant talent in the animal kingdom. A visit to a glowworm habitat, such as New Zealand's famous Waitomo Caves, becomes an almost otherworldly experience as visitors witness what looks like a star-studded night sky underground. The complexity and diversity of bioluminescent life forms remind us of the sheer inventiveness of evolution. As we close this chapter on our luminous narrative, we hope you've gained a new appreciation for the brilliance of the natural world, a world that glows with more wonder and mystery than can sometimes be believed. We've now illuminated the marvels of bioluminescence across various spectacles of life, from the vastness of the oceans and the intricacy of symbiotic relationships to the ingenious survival strategies of land-bound organisms. Each flicker and flash, each pulsating glow within the organisms we've discussed, is a brush stroke in the portrait of life's incredible capability to adapt, survive, and communicate in our mesmerizing natural world. Our journey does not end here, as there are countless other luminous tales twinkling in the dark, awaiting our discovery. So keep exploring, keep questioning, and keep the light of curiosity burning bright.